Welcome to this tutorial on a different perspective in Python programming. My idea is to approach programming in a more entertaining way so that you can use the techniques and the methodologies that we'll cover here on your daily tasks. So I will come up with 3 to 4 functions where we will ask the user for input, and based on their input we will execute the respective function. So let's just take notes from a very high level what we're going to do. So let's say the first function would be the API, or yes, this is API interaction and data parsing, particularly JSON. And the goal here is to connect to software with API capabilities and then be able to communicate back and forth. So for the sake of this demonstration, so what I'm going to use is the Cisco DNA always on standings. That is publicly available. Second one function, I would like to implement maybe a search function. Search, I will say, and directory traversal, where we will be searching for a particular file or extension, and then consequently we'll generate a report. So on top of this, once we're done, so I can say this function also performs output redirection. Fine. The third one, I would say, let's just create a simple TCP server. And I would say that would be enough. So, however, a basic understanding of the concepts is assumed, right? So obviously you're familiar with variables, functions, loops, etc. So let's start by importing the required module. So I'll start with the OS that will be relevant for directory traversal, JSON, interacting with the JSON, request, mega HTTPS one, socket, where we will create a TCP socket, a base64, where we will encode ASCII to base64, and that is one of the requirements for authenticating against DNSSL. So I'll explain as we go through. So the first function is supposed to be the API interaction. So let's just start by defining that function. So I would say the API. That can be the name. What we'll have here is a variable. It's called as vbase, where it will be provided by the user. And then we'll we'll complete the function later. And second function will be research, where we'll ask the user to provide the extension. Third one will be VPCP, where or should be provided. Let's just open up the main function. The way we do this obviously is main is then and we can start. So but the logic of this program is that we will be asking for like the input from the user. So in order to have like a sort of infinite loop, we 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 are going to use a combination of while and if else. So I'll create a variable called precondition where I'll feed that to the while, and while will be iterating for the code underneath and will be indented. Then we will print is type. Let's just input. Let's just print the options so that the user can see like the provided functions. First one, API, so I always press A to interact with the DNAs. Type X string for extension. TP create TCP button. Says for this option type X to X. Then we'll create a variable called input load or save or store the user's input to this variable where we can just go through like the conditionals. So I would say your choice. Based on that, I would say if written is the first one is A, we'll get some action. And the action here is just simply to call the API function, and of course we have to pass the URL. And so we will need to create another variable, the same name, input the user DNA where URL for, and then we'll call the function. Other one with waiting is variable called VXC input extension function V extension. last one is T. Okay, where we will just input the user, which is create variable phone report, and then input port number, and then basically TCP, and we will pass the port onto the function. And the other one, and okay, I just had like me stop because it should like if elif. That's how we implement the logic, because it is an equivalent to switch case in C or C++ if you're familiar with that. So and the other elif is vn exit. So simply, so what we can do here, because we have this variable and it's true, we just say to false. It will just end the program. And else to account for errors. So we can say else the user input was anything other than what is supposed to be based on the options provided, we can print run off. And I think that would be enough for this block of code in the main, because we have all the functions. And so let's just start by defining the functions one by one. So we start with the vAPI. So what we'll need here is to authenticate against the DNA server, and if the authentication is successful, a token will be returned, where we'll need to grab that token for further API calls to be able to interact. So the way we do that is through requests module. So let's just create a bunch of variables that would be or will be fed to the one of the methods. In this case is the post. So let's just start by creating like the VM. And what I mean here is where we will call the particular API for the authentication. And in order to figure that out, if you just pull up the DNA Center, you can go to like developer toolkit, and regardless whatever software you will be using, there will be like a documentation where they most probably have documented the way you have to interact. So in this case, so we can see the authentication API is here, the method is post, this is the URL. The cool thing is that we can try this out to see like the actual URL. And the reason I created a variable vbase is that the user is just supposed to provide this part. The rest we have to add to the user's input, like we need to concatenate. So I'll just take this part that is for the sake of authentication. We have the variable vint quotation mark. I'll add it here. We have a vbase that has been passed vint, and I'll call this for another variable called VURL, where we will just create the whole URL. So adding the HTTPS plus, where we concatenate the vbase to this string plus vn. Now we have the URL. Then we'll need to work on the way we have to craft the HTTP packet. So in order to do that, we need like a header. So I'll create like a variable, and the way it works is you need to create dictionary. So in this case, the keys are one is the content type, where you specify application JSON, and the other is authorization, where we'll have to provide. So this is the point here for the way it's been designed is that we cannot pass the user and password directly to the DNS server. So what we need to do is to like create base64 and then pass that as the authorization. So let's just take one step back and we'll create a variable called user with user. We'll input the user and asking for the user. So it's a user. We pass. Input the user again. Pass. So we have the user and password. And so first thing first, let's just create another variable called VString, where we will, because the way we are supposed to kind of create this, or encode this string is to first concatenate them using like a divider, I would say, in order to distinguish between the user and password. And that divider is technically common. So I'll create this VString where I'll just concatenate user plus this divider as a colon, and then password. So at this point of time, we'll have the VSTR, and that is the expected base string, I would say. Then we'll invoke, and we'll use the same variable. I guess that should work. So we'll have to encode this to ASCII, because prior to that it's just a string, and the input for the base64 function to begin with should be ASCII. So we'll just encode that to ASCII, and then I'll create another variable called VB64 where I'll invoke this module base64, and from base64 we encode VSTR, where the ASCII equivalent of the username and password has been stored. So we have the VSTR encoded in base64, and there is another outstanding step here, and to do that I'll create another variable, and or technically we can use the same variable, but it's better to use another one. So I would call this VB64s, where again I need to convert this, to decode this back to ASCII. So then I would say VB64 at this point of time, that has been converted to base64, decode this to ASCII. And I hope it is like all that is required at this point. Now let's just maybe we can print the screen to see if it will be like the correct base 64. So this is B64S. Let's just compile the program. And I have, okay, the authorization, okay, there, because, you know, I created all these variables to just be able to provide the authorization inside the header. So let's just add this authorization variable here. That is the one we just created. And the TCP, okay, because yeah, I forgot my comments after my TCP function. Expect. I have an indentation issue. Where is that? And the reason is that they are have defined from let's just add return 0, compile it one more time. Yeah, that was the reason. So regardless, so we're gonna test the API in terms of to see if we will get the correct base 64. So the username is there and the user ask for and then let's go. Let me see. Yeah, obviously, I think yeah, this is like the correct base 64. So let's just exit out the line. Okay, cool. So at this point of time, we have the base 64, but that's not yet enough. So the way that we have to pass that, like in the HTTP packet, is just we need to add like another keyword, and that's the way it has been designed. So let me see if I can just add that to this variable here. We will need this keyword here is basic. Then let me just concatenate it one more time, B64S. Let's just print it one more time. B64S. See if we will not generate any errors. So DevNet user. Let me see. Okay, basic. So that's enough. Exit out the program. So now we can proceed here. So we were able to produce the correct base 64, and now is the time to invoke another module. That module is requests, where we'll call a method called session, and then we inherit the properties of that object. So and then we can interact with the DNA center. So I'll create a variable called reSession and then requests dot session. Now we will be able to use all the methods available through this module. In reSession, I'll create another variable called response where I will call the session, and for the sake of the authentication, I'll need like post, and the expected like parameter is the URL, where at this point of time I have stored it URL. Then I need the headers, where we just crafted the header and the header. And since we don't have like valid certificate, we have to set verify to false. So, and we can come up with a conditional, and at the same time, so the response will be like a JSON in JSON format, so we will need to unpack that. Or let's just, for the sake of this demonstration, let's just print what we have here. So let's see what we get in reader response after this call. I'm running the program API functionality. Let me grab the URL of the DNA set. Sandbox dnac.cisco.com. Get back here. Grab the user. Okay, so as you can, so I was able to get a 200 in the response, meaning it was successful. But in order to get to see the content, we will need to technically encode, convert the content into ASCII. And there's like a lot of ways to do that. So one would be to say real response content decode. So we can say simply UTF -8, where it will be technically human readable. So let's just run the program one more time. A DNA server, every user. So as you can see now, I was able to get this dictionary where there is this like token, where the token is the key and the value is this one. We'll need to use this value for further calls for security purposes, right? So and there is also another way, so let me show you a better way maybe to get this in a JSON format, and that is because I guess what I did, that's just, it looks like a dictionary, but it is technically a string. I don't remember off the top of my head, but I would say like a more optimized way is to just use the JSON module. That's it. And let's just print this out. Yes. And the way to extract this token is simply, since this is a dictionary, we can easily call that out by just opening a bracket and then calling that key. In this case, this key is token. So we will have this printed out, hopefully. So let's see. I think I should have used like dot if I'm not mistaken. Sometimes no, this is not the correct. So this is the response.json. This is token. Yes. So the issue was that I put like the token outside of like the other parentheses where I should have just appended it to like the JSON function. And as you can see, I have the token here. So let's just create another variable. So I'm not gonna need that principle because I just wanted to show you how it works. So I'll create like a variable read token where we will store this token, and technically, of course, it could have been more intuitive, this program, in a sense that I could have put like while loop checking to see like the authentication has been successful to begin with, but for the sake of brevity, I'll leave that up to you. So now we've got the token. So let's just find like an API that would kind of return sort of value. And I remember there is like one of them that kind of provides all the devices available. So let me see if that was the okay on the devices. Gets device list, so returns list of network devices based on the what looks solid. Let me see. Okay, I think on this. Okay, so it's cool. So now I have, because what I'm trying to do is just finding an API call where there will be like a sort of response where we can just go through the response and play with it. So this will be my other API call. So I grab that part. The ends or the end doesn't matter. Because at this point in time we're done with that variable, so we can just override whatever lies in it. And I think it most probably is the get method, because yeah, we're just getting like response. So let's create the header for this call, and all we need to provide is obviously content type. Application JSON. On top of that, we'll need to pass this token, and the expected parameter is x token. And here we'll pass token, right? So we have the token, so let's just create another like variable called meeting, where we will call the session. This time we'll use the get method, and obviously, okay, so I need to create like new URL because it's a different URL. Okay. The URL here is like HTTPS, right? Rebase plus this VN and just create it. So we have the URL, we have the header. So I'm just gonna call this URL headers, the header, and obviously verify false. And it's better to call this via response because this is technically a response. So we will have the response here, column number and data, where we'll just use the same JSON to unpack what's within. Now let's just end the end date to see everything's set. So I would say as you can see, I was able to just get the response back, and as you can see, this is like a dictionary technically when you look at it, but there's like another point here, and this is like an embedded list of dictionaries. That's what it's called. Because the first key is just like the response, but the value is, as you can see, there is like the bracket, and then there's curly brace, meaning that this is a list of dictionary, and we'll learn in a moment how to parse, go through, iterate through like the list of dictionary. That's pretty simple. We'll need to use a nested for loop. So what I'm trying to do here is I didn't like the way it was printed. Okay, DNA server address, so and data. So let's just say for key in and data, which is our dictionary or list of dictionary. Oh, like yeah, that's like the first dictionary, right? So this will just return the list, and then we will need another for loop where I will say for we item in key. That would be pretty much it. So we can just print like only items that would be the keys in the embedded dictionary. And in order to get the values, I'll need to say, what you have to do is to say key, maybe, let me see, key in their values. Okay. I think that should be enough. Let's just see. And as you can see, there was an error. So let me see what was the issue with my syntax. So I have for key. Okay. I unpack. Okay. So the issue is what I put was to first just fetch the embedded list of dictionaries, and in order to get there, we need to just use the like the parent key. In this case, it was, you remember, response. So we just add it here. And if you remember, it's the same thing that we did with the token. So we just parse the JSON, and then we call the token to get the value. Now here we need the value of the first key, and in this case the value is the list of dictionaries. And now I have the correct list of dictionaries stored in the end data, and now we will iterate through like this list of dictionaries correctly. So definitely. And as you can see, I have like the keys and their corresponding values printed. And of course, you can even do some sort of like redirection, creating a report, or just you can be looking for a particular key saying, I just want to have the software version printed, and so on and so forth, right? So I would say we're pretty much done with this first function. So let's just move on to the other one, which is search. So in order to define this function, we will need to leverage the OS module, and from the OS module we will need to invoke the walk method. That is the method that will just walk through like a folder that you will provide. I'll create a variable called vdir, where I will just say, okay, this is my root directory. In this case, this is like Linux operating system, so that's how we just represent root. And then I'll just, create a for loop, and I'll explain in a moment. We add ed and os.walk vdir. And the way it works is that the outcome of os.walk accompanied by this VDIR, which is the root directory, is that there will be 3 values returned. The one will be like, the parent, like path, then the directory and the file name. And for the purpose of this function, the v file is the one that is significant for us, because we will need to find a particular extension. That extension, in order to do that, I will say for file or for vex in v file. Now I'm just going through every single file that's been returned by the v file, and in this case v file is the name of the file. The v extension is that particular string of the file. So we will need to just find a particular extension, right? And the way you do that is just pretty simple. And you say vx if it ends with and here we have the extension coming from like the user, and if it ends with, for instance, an if ends with the extension, so that is like the interesting extension that we would like to extract, and let's just redirect it to like a file. And in order to do that, I'll use another kind of module, and it's just a built-in module. It's with open. That's how we interact with the files. And the reason I use with is that it will take care of like opening and closing the file, and it deals with like all the handles and objects in the most optimal way. So I will just provide like a path. In this case, let me just find a path here where we can store right now. Okay, so let me just grab this. I can just store this file to documents. Okay, and let's just name it rerep.txt. And the mode in which I would like to open this file is append, because I would like to append. I don't want to overwrite. And then I'll call this as, this is the handle of the file or the object where we can interact with that file. Let's call this v-f1, and I would say just write to this file. That's pretty simple, and that's how powerful Python is. So you can say write, and this technically the variable that's been found, that's vext. And to make it prettier, we'll just every single time we will add like a new line character as well to have like better output. So it means like enter. So after every single file has been written, a new line will be appended where it will just go to the next line. The output will be more readable. So we're pretty much done with this function as well. So let's move to the last, which is the VTCP. So the port has been passed. So we'll need another variable called, I'll call it host, where we'll provide the IP address, in this case, loopback. The module required here is socket. So in order to invoke that, let's just create a variable called vSocket, where I'll call socket.socket. And the way it works is that you have to provide the address family in this case, which is IPv4, and that would be socket.AF inet, and the other one is the type of a string that you would like to open. In this case is is TCP, so that would say socket dot string, socket underline string, and it's like a neat way of coding to use with as well here to take care of like this object. I would say with this socket, so the object that I would like to be created as vSocket, and then we can interact with this object and just invoke all the methods within it. So the first method would be vSocket.bind, where we will have to just bind the host, which is the IP address, to the port. There's one point here, we need to use typecasting because the expected value is integer. So I just converted the port because the v port is in a string provided by the user. I just convert that on the fly to integer for the sake of this bind. The other expected method is vSocket.listen, where we will start listening, and then consequently we will need to invoke another method called accept. And the point here is the values returned by this accept will get two values, and we will need to store them in two variables. So I will call the first one vcon and the second one vAddress. And what they represent, the vcon is technically the object where we can interact with that TCP stream, and vAddress is technically just the IP and port that the connection has been initiated from. So the one that is important for the sake of this function is the vcon, because that's how we interact with that channel. So in order to do that, so again, we can use the with vcon to take care of like only management in terms of like the objects and file descriptors that has been created by this accept. We will use the with and then a while, and the while is true because I want this channel to be permanently on as long as there hasn't been any like exit that would just signal a termination. So I would say while true, meaning just iterate whatever is underneath you, and that would be in this case, okay, I would say if so let me just store the n. So I'll create another variable called nsock. Let's call it nbuffer, where I will say vcon. The way we did this method is the one that will be dealing with like the data coming through the, TCP stream. And the recommended size here, we need to provide like a size, and that is like 1024. And I have that stored in M buffer, and I would say while true. So I would say while true, if M buffer is exit break, else continue, do nothing. I know, sorry, and else we need another method, and that is we can echo back whatever is coming from the user back to the user. So that is what this says technically. But there's another point here, and that is the variable, the value returned by the beacon.directory is like in like a data set, or like it's a data type called like byte, and there is like a bunch of extra characters added to that variable. So we need to find just this particular string, and based on that signal the break. But right now it will not work, and I'm going to show you. So let's just compile the program one more time and just test like the two recently added function. So here the first, okay, the second one was the extension. Let me just say, okay, the extension that I'm looking for is .txt. We could have made it more intuitive by just printing, okay, it's been successful, you can find the report. But for the sake of this demonstration, it doesn't matter. So let me just see if the file has been created. So let's just go here, see cabinet document. As you can see, that the vref.txt has been generated. So let's just get the content more. As you can see, all the files with the .txt extension being extracted. We have the report here. So okay, first function. The second function is working as expected. So let's just test like the TCP, and obviously I know it's not gonna work in terms of like the exit. So let's just say TCP, the port is gonna be 8080. Okay, let's just check out if this server is listening on 8080. And in order to do that, I was netstat NAN grab 8080. And as you can see, it's just waiting for the connection to come through. So let's just tell it to 127.0.0.1.8080. And the channel being has been established, and we can say just hi. And as you can see, okay, there's another issue with the code. And let me see what that is, because it takes at least one argument. Oh, I forgot to provide the send all. Yeah, because once you invoke this like method, so you need to say, okay, send the data back to the user. But what is that data? I forgot to say the data is like this end buffer. Time T port number 8082 established. Hi. Okay, I'm getting a lot of hi here. That's because of the logic. Okay. So I just unknowingly created like an infinite loop where it's just, I think it's because of the while that the logic is, let me see, and else, because yeah, I said else send this, and At the same time, why is it just going back and forth? I think I need to say continue. Let's just see. So that it will just, restart the loop. And oh yeah, no, it's not because of the continue. Because I need to put this buffer inside the while loop, and I just put it right outside. So that was the issue. So let's just put it under the while so that we can have this weekend object over there. 8080. Okay. You can see now it is working because the logic is correct, but the issue is that the exit is not breaking. So whatever I say is just getting echoed back. And the reason is because I told you is the data type that's been returned. And in this case, it's we need to just split this variable and change it, and then just find that particular string that we're looking for. In this case, is exit. So maybe an option would be just let me show you how it looks right now without manipulating this. So I'll just print the M buffer here. T8080. Okay, it is still open, so let me just use another port. T8082. So connection is use 8082 high. Exit. So if we get back to pie chart, we can see this is currently the way this is being stored, and obviously it would not make that conditional statement true because we're looking for exit. But here we've got some extra characters padded, so we need to remove those padding. So what I'm gonna do, because you can't change the M buffer. I mean, you can technically change it, but you need to store it in another variable, and we have to use typecasting. But it should stay byte because that's what the send all takes. And as you can see, even like in the description here, the data type is buffer, and that's like of the type byte. So I would say, let's create another variable. I would call it mbuff2, or let's say mbuff_str, where we have converted to str, and I will just call the mbuffer, do a typecasting real quick, split. So what I need here is just, let's just start by the quotation saying okay, split by or maybe we can just split by like a backslash, and let's just print that in buffer str real quick. Recompile T8080 8085. Go back here. As you can see, we were able to split, but now the issue is that we can access technically. So we have a list with 3 elements, 0, 1, 2. Now, if I call out the first element, that it looks like this. So let's just find it one more time. T8082 still open. What was that width good for? So 8080, this one's still open. 8084 exit. Let's go back here to see how it looks. Okay, as you can see, it's way better. I was able to access like the first element in the list, right? But there is still an extra B quotation that I gotta remove. And in order to do that, I'll just call another split. Simple as that. I always say that I split uh, split this with, I think it's gonna work like this. So let's just print it one more time. A exit. Okay, it worked. As you can see, I was able to, no, it didn't. So the reason it exited out was there was an error and most probably untype. Because split. So let me just do another thing. So I'll just store the output of this into, so I would say M buffer I want you to split this like this, and now it's above still 8081 high. Okay, I'm getting the high. Exit is still getting. So let's see how it looks like. Okay, that's it. So I was able to split this kind of list will further using like the quotation, right? And what I need to do is to access this list. This list has got two elements, 0 and 1. And in order to access that one, it's as simple as saying, now this time M buffer dash 1. That would be it. And that's what I'm gonna change my condition to. So I would say mbuff str1. If it was exit, and you can play with it, do a lot of things. Like if this was this, do that, and so on and so forth. And I always say if mbuff str second element that's technically like indexed with 1, because indexing starts at 0, so 0 1. So if it's exit, break, else just echo back. Let's just run one more time. 80 high. Now everything's just getting echoed back. Exit is breaking. And that technically brings us to the end of this tutorial. So let's just wrap it up by summarizing what we did. So we just created like a main entry in the function, like in the code, where we created a while loop and the condition was checked and the condition was set to true, and we just printed like messages to the user, and then we interacted with the user, and per like the interaction we invoked different functions, right? The first one being the API, where we interacted with the DNA center. The second one being the extension, where we technique looked for a particular extension and redirected the output to like a file. And the last one was the TCP server, where we created a TCP stream and then we echoed back all the characters back to the user, except if it was like a termination signal, and that was exit. And we just played with different data types and did a lot of parsing in terms of JSON and so on and so forth. I hope it has been informative for you.